And please do send the answer in one. Like after solving all these three questions, you are going to send me the answer of all three. Rabia, is that clear?
Yes, sir.
Oh, Aisha, you are going to solve all the three questions and then send me the answer of all three together. Like one, uh, you are going to write question number one, answer A, B, C, D, or you can write in Roman numeral 1, 2, 3. Very good, Rabia. All the three answers are correct from you. Aisha, waiting for your answer. Aisha, am I audible? Aisha, are you there? Okay, Aisha. Aisha is not responding, so I'm moving to the next. The next three questions. Aisha, are you there? If you're facing any kind of doubt or problem in these questions, let me know. Rabia, go for next three questions. Aisha's net is not working. Very good. The fifth one is correct. The sixth one is also correct. And the seventh one is also correct. Okay. Please do solve the next three questions. I'm adding two more options as it is not present here. Just wait a minute. Sorry. The remaining two options are here. Aisha, is your Wi-Fi working good? Am I audible to you? Rabia, is my voice clear?
Yes, sir.
Okay. Go for the next three questions. The question is not tough, but it's conceptual, and moreover, it's mostly theoretical. We will go for numerical as well, the stuff, but after clearing this type of questions. Uh, the answer that you have given for question number 8 is wrong. Question number 9 is correct, and for question number 10, it's correct. Now, colligative properties depend on. Basically, I told you when we define, basically, when you have learned about the colligative properties, it depends only on the number of solute particles, not on the nature of the solute particle. So the answer will be second, not the first. Colligative properties does not depend upon nature of solute particles dissolved in the solution. It depends upon nature of solute particles. It depends upon nature of solute particles present in the solution. Are you getting my point?
Yes, sir.
So this is the right answer. And remaining answers for 9 and 10, it's correct. Moving to the next. Go for this. It's good that you are able to solve almost all the questions. For question number 11, it's correct. For 12, it's also correct. And for 13, it's also correct. Very good. Go for these two questions. Read the statement carefully. Very good. The question number 14, you have given the correct answer. What about the next one? Next one is quite easy. So the question 15, I didn't get it. Okay, no problem. The values of Van 't Hoff factor. Please be careful about this. Van 't Hoff factor has different formula, in which one of the formula of this Van 't Hoff factor, I, is equal to number of solute particles after association or dissociation. Association, that means basically two or more number of particles combined to form a single particle, or dissociation, that means one particle divided, or one particle give you more than one particle, upon number of solute particles before dissociation, before association or dissociation. I'm going to explain this because you are continuously making mistake about this. Let's say there is a particle or there is a solute which is KCl, and you know KCl is an anionic compound and it is electrolyte. It is electrolyte, non-electrolyte or electrolyte. So it will be dissociated into ions K plus Cl minus. Now see, before this, since it is dissociated, one molecule give you two molecules, so it is called dissociation. And you can see before dissociation it is only one, so the value of I before dissociation it is one, and after dissociation you can see 1 plus 1, that is equal to 2. So the value of I for KCl will be 2. Are you getting my point? Yes or no? You are not audible. Okay, am I audible clearly to you? Okay, let me check my mind. Everything is good. Okay, now go for NaCl. You know that NaCl, again electrolyte. Again, it will be divided into Na plus Cl minus. Before this, since dissociation is taking place, are you understanding the difference between what is association and dissociation? Yes or no, Rabia? You can reply me in chat box as you are not audible to me at all. Let me change this now. Yes. Can you speak again? Okay, not a problem. So before dissociation, it is only one. Before dissociation, that comes in denominator, and after dissociation, 1 plus 1, 2. So again, the value of I for NaCl is 2. Now K2SO4. If you go for K2SO4, it is also an electrolyte which will be dissociated. You can see K plus SO4 minus 2. You are going to balance it as well. 2 potassium on the left hand side, so I'm going to make it 2. So the value of this after dissociation, 2 plus 1, that is equal to 3 by 1, which means 3. So the value of I for KCl will be 2, for NaCl will be 2, K2SO4, that is K2SO4 3, and only for this, so the answer will be 2. Are you getting my point? So these are all examples of dissociation. How you are going to calculate for association? As I told you that two or more particles of the solute combine to form a single, like let's take an example of CH3 C double OH. When you are going to mix this, you know what will happen? This will form a single compound with the help of hydrogen bond. You know what will happen? OH. Now just let me write this OH as this, and you can see double bond O and this. Now, you know what will happen here? There will be hydrogen bonding between this and it forms a single molecule. So if you are going to check the value of I Van der factor, you can see before dissociation, it is 2 moles. So you are going to put this before in denominator, and after association is taking place, 2 mole is converting itself into 1 mole. So it is called association. It associates. So the value will be 1/2. So this is an example of association, and all the 3 examples that I have given you is dissociation. Now there are some compounds which is neither associate nor dissociate, like glucose you can take, or sucrose C12H22O11. If you are going to put this in any solvent, in water, it won't dissociate. It won't dissociate or it won't associate. So what will be the value of I for this after association, or since association dissociation not taking place? So after it is 1 and before it is also 1. So the value here will be I is equal to 1. Got it? Okay. Can you change the slide? Okay. Moving to the next question. Please do 16, 17, 18. Let me know when you are done with this. Or 16, it's correct. 17, it's also correct. And 18, it's correct. Very good. The next two questions, please read it carefully and then give the answer. Please do. Very easy question. Next answer. Very good. Very good. Please do this. Very easy question. Question number 26. Very good. Moving to the next type of question, which is match the column. Please do. This match the column almost revives all the concept of solution, type of solution. You can write in the option like one and whatever is the option A, B, C, D, whatever is the right three like this. Or you can direct like one A, two B like this. No, no need of hyphen as well. Quite easy it is. Are you done with this? Rabia, any answer? Seven. Uh, Please do speak up or send message in chat box as you are not audible. Are you able to solve this? Yes or no? Okay, then do solve. Should I explain? Okay, I'm gonna give you the answer, just match it. As you can see, this is your saturated solution. Saturated solution is the one in which maximum amount of solvent is dissolved, can be dissolved at a given temperature. So the answer will be D here. Just match with this. Binary solution, that means two components. So you can see this will go with C. Isotonic solution, same osmotic pressure. Hypotonic solution, the one which has lower osmotic pressure than the other. Solid solution, a solution in solid phase. Hypertonic, that means more osmotic pressure than the other one. So this will be. So I'm gonna match your answer with this. With 1D, with 2C, with third A, with fourth B, fifth F. Very good. Very good. No, this is also quite easy. It's just it will revise your formulas of what we say, not also and all the formulas basically. This one is more easy than the previous question. 1C, 2D. Elevation in boiling point, you can see this will go in D. In depression in freezing point, this will end with moderate pressure like this. So both are quite easy. I'm gonna give you one more question about this. It's about concentration time distribution. It's also quite easy. Very easy question. Let me know when you are done with this. So very good. This one is also correct. Now moving to the next type of question. This is also easy. Then I'll give you. Please do this question. Option A, very good. You can go for this question, last question. Very easy. In the next class, we are going to start with this electrochemistry. And in electrochemistry,